Uh, First stage we went smoothly. We got the integrand as root of sin x by 2 plus cos x by 2 whole square. Up to this step it's okay, perfectly okay. Then afterwards some sort of confusion took place with me. Actually I could have easily avoided had I noticed that this is nothing but mod of sin x by 2 plus cos x by 2. Now I need to determine whether this, what is the actual magnitude of this, whether it is sin x by 2 plus cos x by 2 or its negative. An easy approach would have been, write this as root 2 into mod of 1 by root 2 sin x by 2 plus 1 by root 2 cos x by 2, which is sin of x by 2 plus pi by 4. Agree. When x is between minus pi and minus pi by 2, this will be between minus pi by 2 and minus pi by 4, plus pi by 4 will be between x is between minus pi and minus pi by 2. I don't remember what the actual limits were. Were these the limits? Yes. X by 2 will be between minus pi by 2 and minus pi by 4. Add pi by 4 to it. How much are you getting? Minus pi by 4 to 0, a part of fourth quadrant. Is sign negative in that quadrant, in that case? Yes. Therefore, modulus will be, that's all. It was so simple. Actually, I went through the graphs of the two functions, sine and cos, found which is above, which is below, what is the difference. So many complicated ideas I brought in. Actually, those things were not necessary. It would have been smoothly covered like this. Now, yesterday's continuation. For x between minus 1, 1, 2x will be between minus 2 and 2. For every number between minus 2 and 2, will same formula apply for fractional part? No. For numbers in different intervals, you will have different expressions. For numbers between 0 and 1, you know fractional part is itself. For numbers between 1 and 2, fractional part is actual value minus 1. For numbers between 2 and 3, fractional part is actual value minus 2. Am I right? For numbers between minus 1 and 0, fractional part is actual value plus 1. Agree? Like that, different formulae apply in different intervals. So, to obtain the actual function to be integrated, we will have to break the interval of integration into several pieces. One simple idea may be, you draw the graph for the function that you are required to integrate, fractional part 2x. Let me try drawing a graph for that. My interval is from minus 1 to 1. When x is between 0 and half, my 2x will be between 0 and 1. Agree? Therefore, fractional part will be itself. So, my function formula is simply 2x, y equal to 2x. What is graph of y equal to 2x? Line passing through origin, slope 2. Okay. Agree? We need not give any importance to the endpoints, inclusion, exclusion, but if you want to be precise, okay, this is the graph. Left hand point included, right hand point excluded. For numbers between half and 1, 2x will be between 1 and 2. Agree? Fractional part is actual value minus 1, 2x minus 1. What is the graph? Another line. Line parallel to this, slope is same. Passing through now this point. So, it will be simply a parallel line segment. Similarly, on this side also, you will have parallel line segments. This will be the graph for the function fractional part x. This is the function which I am asked to integrate. What should I find? Simply the area enclosed by the graph, the x-axis, the ordinates at minus 1 and plus 1. What is that area? Simply this triangular area, this triangular area, this triangular area, plus this triangular area. Are all these triangles of the same area? Yes. In my graph you do not see, because graph has not been drawn properly according to scale, but actually all the triangles are of the same area. So, what will be the total area? 4 times, choose any one of the triangles, say this triangle, base is half, height is 1, area is 1 by 4. Agreed? One of the shortest methods. Next. To find the integral from minus 1 to 1, signum of sin x. The interval 0 to 1, is it part of one of the 4 quadrants, or is that interval covered by more than one quadrant? Our interval, one part of our part of the interval of integration is 0 to 1. Is this part of one of the 4 main quadrants, first, second, third, fourth? Yes, it is completely contained in the first quadrant. And therefore, throughout this interval, your sin x will have the same sign, positive sign throughout. Signum value will be 1 throughout. Don't bother about the endpoints. When x is between minus 1 and 0, the bounding line making angle x with x-axis will be entirely lying in 4th quadrant. And in the 4th quadrant, sin x is negative. So, signum will be throughout the interval. The signum will be minus 1. Again, no importance need be given to the endpoints. What is that we are required to find? The area covered by the graph, the ordinates and x-axis, this area. and you easily find the algebraic sum is 0. Because these two rectangles are of the same area, one is positive, another is negative, algebraic sum is 0. Even if you carry out integration in the calculus method, same answer will be obtained. Integral is minus 1 to 0, minus 1 dx plus 0 to 1, 1 dx. Integration of integer part of mod x for x between minus 1 and 2. First, let me consider numbers between 0 and 1. For numbers between 0 and 1, modulus is itself, and the integer part will be 0, throughout 0. For numbers between 1 and 2, modulus itself, integer part 1. For numbers between minus 1 and 0, modulus is negative. It will be a number between 0 and 1, and therefore integer part 0. Therefore, what we are required to find is area of this rectangle. Agreed? Right, I think. Yes. Now, your integrand is integer part inside, modulus outside, modulus of the integer part. Interval is the same. Again, as before, if the number is between 0 and 1, integer part will be 0, modulus will be 0. Okay. If the number is between 1 and 2, integer part will be 1, modulus also will be 1. Modulus of the integer part will be 1. If the number is between minus 1 and 0, integer part is minus 1 and modulus of that again minus 1, not 0 as in the previous case, now it is 1. Integer part is minus 1, when you apply modulus it becomes 1. So, what you are required to find is the sum of the areas of these two rectangles. The rectangles have the same area, so you need to find one rectangular area and get it multiplied by 2. Minus 1 to e mod of log of mod x. Suppose your x is between 0 and 1. Graph of x is between 0 and 1, modulus itself. The function log x will have graph agreeable for a modulus nantra. Now I have not yet gone to the final function. I am just concentrating on this portion, log of mod x. For x modulus itself, I have applied logarithm and I am getting this curve. Because as x tends to 0, log x tends to minus infinity, at x equal to 1, value is 0, function is an increasing function, increasing from minus infinity to 0. When you apply modulus to this, to get the final function that is to be integrated, the curve gets shifted to the positive side and the graph becomes this. Okay. Then, for numbers between 1 and 2 or between 1 and e, graph of log x will be a monotone increasing curve. It is at 1 log 1 is 0, at e log is 1. Throughout the interval, it will be a monotone increasing function. So, On the right of 0, what we are required to find is the area bounded by this curve, the y-axis, x-axis, and the area bounded by the curve, the ordinate at E, ordinate at 1, and the x-axis. The sum of these two areas is required as part of the integral to the right. Now, on the left of the interval, left of the y-axis, x is between -1 and 0. Modulus will be a number between 0 and 1. For a number between 0 and 1, what is log x? What is the graph of log x? It will be like this. Agree? For final modulus I have not yet taken. I am just considering log of mod x. Mod x is a number between 0 and 1. Therefore, when you apply logarithm, at this point you will get the logarithm 0. At this point logarithm will be -infinity. Graph will be something like this. When you apply modulus to it, it will move above. Okay. So, this is what we are required to find. Clearly from my figure, required area is twice integral 0 to 1 of log x dx. If I go wrong, correct me, plus integral 1 to e of log x dx. Is there any error in this expression? Yes. What correction is needed? Minus. Right. Because this gives me this area which has not been shaded. What I am required to obtain is this. It's negative. So, minus 2 times integral 0 to 1 log x dx plus this. And this is minus 2 into integral log x is x log x minus x, limits 0 and 1, plus integral log x is x log x minus x, limits 1 and e. At 1, 1 log 1 0 minus 1. At 0, 0 log 0 minus 0. What is 0 log 0? As it is an indeterminate. It is an indeterminate like 0 into minus infinity. At x equal to 0, x is 0, log x is minus infinity. So, it will be not a well defined expression. How do you obtain its value, actual value? The actual value may exist. The substitution only is failing and we are not getting the value by substitution. What you are required to find is actually limit x tending to 0 of x log x. If substitution of the value is not possible, what you are required to obtain is this. This may be imagined as limit x tending to 0 of log x by 1 by x. At x equal to 0, this is minus infinity, this is infinity. L'Hopital's rule is applicable. On applying the rule, I get limit required is same as limit x tending to 0 of 1 by x by minus 1 by x square. From this I find that limit is equal to 0. This product 0 into minus infinity is becoming 0. Minus the other term to be subtracted 0 plus this is e log e 1 minus e minus value at 1 minus 1. Three, 4, 4 minus e, is it? Yes. Minus pi to pi, mod of cos of mod x. First, let me consider numbers between 0 and pi by 2. For x between 0 pi by 2, mod x is itself. Cos x, it starts from cos 0 equal to 1, goes on decreasing, decreases to cos pi by 2 equal to 0. Graph will be a continuous function starting with 0, 1, ending at 0. In the interval pi by 2 to pi, mod x is itself. Mod x also will be a number between pi by 2 pi. Apply cos to it. In the second quadrant, cos is negative. It will decrease from 0 to minus 1. Am I right? Okay. Agreeable, I think. Oh, this I have not marked properly. That's the problem. Okay. Value is decreasing from 0 to minus 1. That is graph of cos mod x. But what I am required to sketch is not just cos mod x, its modulus, its magnitude, its reflection in the x-axis. Okay. Coming to this side, because of the modulus that you are having outside, is the graph of this function symmetric about the y-axis? Is the value of the function at minus x same as the value of the function at plus x? Is it an odd function? No, it's an even function. Because the function is even, graph is symmetric about the y-axis. So whatever I have drawn on that side, same curve will be appearing on this side also. What I am required to find is this area. And by symmetry, it is simply 4 times integral 0 to pi by 2 of cos x dx, which is 4 times sin x to be evaluated between 0 and pi by 2. Agreed? Instead of taking the cos function, suppose you take the sin function, what change will take place? Yes, in the interval 0 to pi by 2, sin x will be increasing function, increasing from 0 to 1. In the interval pi by 2 to pi, it will be decreasing function, decreasing from 1 to 0. On this side, again our function remains even, graph will be symmetric about y-axis, so same curve to be traced reflected with respect to y-axis. Again, what you are required to find is 4 times the shaded area in figure. What is the shaded area? Is 0 to pi by 2 sin x dx. And what is it equal to? 4 into minus cos x from 0 to pi by 2. Okay. Minus, no, not minus, pi by 2 to 3 pi by 2, integer part 2 sin x. In interval pi by 2 to pi, the function sin x, it starts at the point, what will be sin pi by 2? 1. It starts at height 1 and goes on decreasing to reach the point 0 here. That is for sin x. Sin x is a decreasing function having starting value 1, ending value 0 in the interval pi by 2 to pi. When you double the function 2 sin x, the starting value will be increased to 2 and the ending value will remain same as before, will remain as 0. Find the integer part. Integer part will not be same for all numbers from 2 to 0 or from 0 to 2. In one portion it will be 0, in another portion it will be 1. Okay, where will the change take place? Change will take place at the point where 2 sin x is equal to 1. 2 sin x equal to 1 means sin x equal to half. At which point of this interval you get sin x equal to half? You express it in radians. 5 pi by 6. So for x between pi by 2 and 5 pi by 6, sin x will be between 1 and half, 2 sin x will be between 2 and 1, integer part will be equal to 1. Agree? For x between 5 pi by 6 and 5, sin x will be between half and 0, double will be between 0 and 1, integer part will be 0. Okay. Next, from pi to 3 pi by 2. Throughout the interval, sin x will remain negative. It will start its values from 0 and end at minus 1. Double sin x will be starting value 0, ending value minus 2. Somewhere in between it will become minus 1, where at pi plus pi by 6, that is 7 pi by 6. For x between these 2 points, sin x will be between 0 and minus half. Am I right? 2 sin x will be between 0 and minus 1 and 0 properly, and the integer part is minus 1. For x between 7 pi by 6 and 3 pi by 2, integer part will be minus 2. Because values will be between, sin x will be between minus half and minus 1, double will be between minus 1 and minus 2, integer part minus 2. Forget about the end values. Each point, which end point is included, which end point not included, don't bother about that. You are required to find only the area covered. Okay. Coming to over the entire interval I have covered. Pi by 2 to 3 pi by 2 is my interval of integration. Entire interval has been covered. What I am required to find is this rectangular area minus area of this rectangle minus area of this rectangle. This rectangle has width, how much? 5 pi by 6 minus 3 pi by 6. Pi by 3 into height 1 minus this rectangle has width pi by 6 and height 1, depth 1, minus this rectangle has width pi by 3 and depth 2. So this is what you are required to compute. Is it minus pi by 2? Yes, minus pi by 2 is the answer. Integral from minus 1 to 2 of integer part of x plus integer part of x. Conveniently, you can make use of one of the properties of integer part. Yes. For any integral n, integer part of x plus n is integer part x plus n. This applies for every integral value of n, whether n is positive or negative or 0. In this argument of the integral, is this an integer? Yes. Therefore, this is simply integer part x plus integer part x, simply twice integer part x. What is the graph for integer part x or twice integer part x? From 0 to 1, 0. From 1 to 2, integer part is 1, twice the integer part is 2. From minus 1 to 0, integer part is minus 1, double that is minus 2. What is the value of the integral we are required to determine? This area plus this area, algebraic sum. This area is 2 and this area is minus 2, algebraic sum 0. Integral 0 to x, integer part cos t dt, x is an arbitrary number from between 10 pi and 21 pi by 2. X may be any number from 10 pi to 21 pi by 2, what will be value of that definite integral we are required to find. The end point of the interval, starting point is 0, end point is some number between 10 pi and 21 pi by 2. Somewhere here I have x. My interval of integration is from 0 to x. The function to be integrated is integer part cos t. If you draw the graph for cos t, the graph will come out as from there compress. This is pi by 2. Agreeable? Yes. This is for cos x, the graph for cos x. If you consider only the integer part, for numbers between 0 and pi by 2, value is between 0 and 1, integer part will be 0. Agree? For numbers between pi by 2 and 3 pi by 2, the value, actual value will be between 0 and minus 1, so integer part minus 1. For numbers between 3 pi by 2 and 2 pi, integer part again 0. Will the same thing repeat in this interval again? Again in this interval, again in this interval, again in this interval? Okay. At the end, from 10 pi to x, one portion of this will get repeated. My x is behind 21 pi by 2, so the portion to be repeated will be a part of this, not a superset of this, only a proper subset of this. So, one small piece, part of x-axis will be the remaining left out part of the graph of the function. Okay. What is integral from 0 to pi of our graph? It is simply the area covered by this rectangle with a negative sign. How much is it? Minus pi. The width of the interval is pi, depth is 1, area numerical value pi with a negative sign. How many such areas are getting repeated? 1, 2, 3, 4, 5. Agree? And what about this small piece? 0. Our function is a constant function with value at every point belonging to the interval equal to minus 5. Again, I will be using this property, integer part x plus n. For every integral n is integer part x plus n. In this is an integer. Therefore, integer part 1 plus sin x will be 1 plus integer part sin x. So, I will be able to write this as 1 plus integer part sin x. So, inner argument will be x plus 1 plus integer part sin x plus 1. Again, using the property integer part x plus n equal to integer part x plus n, I get the integrand as integer part x plus integer part sin pi x plus 1 plus 1, that is 2. Let us find the three areas separately. What is the integral minus 1 to 1 integer part x? For values between minus 1 and 0, integer part is minus 1. For values between 0 and 1, integer part 0. Therefore, first term integral from minus 1 to 1 will be negative of the numerical value of the area of this rectangle. It is equal to minus 1. The last term is a constant term, so integral will be simply twice integral 1 from minus 1 to 1, which is twice 2. Integral 1 from minus 1 to 1 is 2. Now, the middle term remains. Integration of integer part sin pi x for x between minus 1 and 1. First, let us consider this portion of the interval. X is between 0 and 1. Pi x will be between 0 and pi. What will be the graph of sin pi x? It will have starting value 0, ending value 0. In between, it will attain the height of 1 unit. Apply integer part to this. For x between this point and this point, integer part 0. For x between this point and this point also, integer part is 0. Next, if x is between minus 1 and 0, pi x will be between minus pi and 0. In the interval minus pi to 0, sin x graph will be starting value 0, ending value also 0, but in between it goes to a depth of minus 1 unit. Throughout the interval, integer part will be minus 1. Therefore, integral value will be area of the rectangle with a negative sign minus 2. Minus 1. Okay, depth is 1, width also is 1. Right. Correct. Minus 2 to 2, integer part x square. For the function x square, simple function x square without the integer part symbol, the graph is parabola with vertex below, vertex at origin, end points 0, minus 2, 4 and 2, 4. Agreed. So, somewhere within this interval, the height of the curve, height of a point on the graph will be 1. Somewhere else, the height will be 2. At another point, height will be 3. For points in this interval, integer part will be 0. For points here, it will be 1. For points here, it will be 2. Then it will be 3. We have to mark those points where the integer part changes. The height becomes 1 at x equal to 1. Height becomes 2 at point x equal to root 2. And height will be 3 at x equal to root 3. For x between 0 and 1, x square is between 0 and 1, integer part is 0. For x between 1 and root 2, x square will be between 1 and 2, integer part will be 1. For numbers between 2 and 3, square will be between 2 and 3, therefore integer part will be 2. And for remaining points, integer part will be 3. So, value of the integral from 0 to 2 will be sum of the areas of these 3 rectangles. What about the area on this side? Because of symmetry, it will have same numerical value. So, integral value is 2 into area of this shortest rectangle, width is root 2, height is 1. Next shortest rectangle, width is root 3 minus root 2, height is 2. For the next tallest rectangle, width is 2 minus root 3, height is 3. Root 2 minus final value. Okay. Root 2 minus 1. Right. Width is root 2 minus 1 and height is 1. Right. Correct. Right. First, let me remove the modulus signs and then proceed to carry out integration. Inner modulus will be removed first. The turning point is x equal to 0. For numbers between -1 and 0, mod x is minus x. And for numbers between 0 and 1, mod x is itself, x itself. So this is what I am going to get on removing the inner modulus. Now to remove this outer modulus, x is between -1 and 0, -1 radian and 0 radian. Sin inverse minus x will be where? Not -1 radian, number -1 and number 0, where will be sin inverse minus x? Between sin inverse -1 and sin inverse 0. What is sin inverse -1? Minus pi by 2. Sin inverse 0. 0. So, is every value attained by sin inverse minus x negative? Yes. Therefore, modulus is its negative. Agreed? Agreed? Because throughout sin inverse minus x remains negative. Am I right? I am sorry, I made a mistake. Yes. X is between -1, 0. I am not finding sin inverse x, I am finding sin inverse minus x. When x is between -1 and 0, my minus x will not be between -1 and 0. Minus x will be between 0 and 1. Is it not? So, this will be between sin inverse 0 and sin inverse 1, which are values are 0 and pi by 2. Throughout it is positive. No need to place this negative sign outside. It will be wrong if you place that negative sign. Clearly, x is between 0 and 1, sin inverse x throughout positive, modulus is simply sin inverse x. Just to simplify the computational exercise little bit, I apply a substitution. Replace this by t. As a result, dx will become minus dt. New lower limit will be plus 1. New upper limit will be 0. You interchange the limits, you will find this integral is exactly same as 0 to 1 sin inverse x dx. Plus itself. How am I getting this? Replacing this by a new variable t. My dx will become minus dt. New lower limit plus 1. New upper limit 0. Just to take care of this negative sign, interchange the limits. Instead of having 1 to 0, it will become 0 to 1. 0 to 1 of sin inverse x dx. Agreed? Later, sometime later, we will be, as another property of definite integrals, we will be noting that for every even function, integral minus a to a is twice 0 to a. For every odd function, integral minus a to a is 0. This is an even function. For that reason also, integral is simply twice integral of sin inverse x dx. And what is integral sin inverse x dx? You will have to obtain it by applying the method of integration by parts. X into sin inverse x minus integral x by root of 1 minus x square dx. Am I right? Limits to be applied are 0 and 1. For this, when you apply the limits, you get 2 into x1 sin inverse 1 pi by 2 into 2 will give you pi. At 0, value is 0. Minus integral 2x dx by root 1 minus x square is same as integral dt by root t, where t equal to 1 minus x square. Yes. So, integral will be integral of t power minus half is t power plus half by half is 2 root t. You have taken care of this negative sign, you have also taken care of this coefficient. Everything has been taken care of. So, plus 2 root 1 minus x square to be evaluated from 0 to 1. Agreed? Is 2 minus 2. Hello? First, to get rid of those special functions, special kinds of brackets, flower bracket and square bracket, let me break the interval of integration into several parts. The first part I will have will be minus 2 to minus 1, next part minus 1 to 0, next part 0 to 1, and final part 1 to 2. In the part 0 to 1, integer part is 0, whatever be the fractional part, my integrand becomes 0. In the part 1 to 2, integer part will be 1. And fractional part for a number between 1 and 2 is actual value minus the integer part, that is 1. Fractional part is x minus 1, integer part is 1. For numbers between minus 1 and 0, integer part is minus 1. And fractional part in any case is actual value minus integer part. So, in this case also actual value minus integer part is x plus 1. In this interval, integer part is minus 2 and fractional part is x plus 2. As before, actual value minus integer part x plus 2. Carry out these integrations, you will be getting your value. This is minus 2x, integral is minus x square, evaluated between minus 2 and minus 1 plus 3, okay, minus 4 into x evaluated between minus 2 and minus 1 plus 1, minus first term x dx, integral x square by 2. Between the limit 0 and minus 1 and 0 is minus half. Next term, minus 1 dx, x, integral is x. When the limits are applied, value becomes plus 1. Okay. Next term 0, last term x dx integral half of x square is 3, minus integral 1 value is 1. Now my integrand is a product function. So even though there is integer part, there is fractional part, I am not preferring the graphical meaning of the or geometric meaning of the integral. I am not trying to find it as measure of some area, because I am having a product. Had it been a sum or difference, I would have preferred drawing the graph and from the graph getting the area and thus obtaining the value of the integral. In this case, I prefer to apply this regular approach only. A fractional part x square to be integrated between minus root 2 and plus root 3. Fractional part will have different values in different intervals. In interval 0 to 1, it will have one value. In interval 1 to root 2, it will have another value. In interval root 2 to root 3, it will have one more value. And similarly on this side, from minus 1 to 0, you will have one expression. Minus root 2 to minus 1, you will have one more expression. And these things will completely cover our interval of integration. In the interval, first let me cover this 0 to 1. X square also is between 0 and 1. Fractional part is itself. when x is between 1 and root 2, x square is between 1 and 2, fractional part will be x square minus 1. When x is between root 2, root 3, x square is between 2 and 3, fractional part is x square minus 2. When x is between minus 1, 0, x square is between 0 and 1, therefore fractional part is itself. When x is between minus root 2 minus 1, square is between 1 and 2, fractional part is x square minus 1. Agreed. Notice that in each of the integrals, x square is part of the integrand. You have x square as part of the integrand here, you have it here also, you have it everywhere in each of the integrals. You can club those parts together and get sum of those parts as minus root 2 to root 3 x square dx. The portions uncovered now are, one is integral minus 1 from minus root 2 to minus 1, then integral minus 1 from 1 to root 2, and then integral minus 2 from root 2 to root 3. These are to be recorded separately. This minus 1 integrated from minus root 2 to minus 1 will give you minus of, yes, agreeable? Minus 1 is kept outside, integral 1 is x, apply the limits, minus 1 minus root 2 minus 1. Then another uncovered part, minus integral 1 dx from 1 to root 2, agree? And last part, minus 2 into integral 1 from root 2 to root 3. This is 1/3 of x cube right? Okay, I think. Minus root 2 plus 2 root 2 cancel. Then plus 1, 2. Then last term 2 root 3 with negative sign. Simplify to the extent possible. First we get rid of the inner special function, fractional part function. We want to remove these special kind of brackets by breaking the interval to minus 1 to 0, 0 to 1 and then 1 to 2. In this interval, our function to be integrated will be simple sin x dx. And in this interval, it is sin of x minus 1 dx. In this interval, it will be sin of x plus 1 dx. Carry out each integration, apply the limit, simplify. Leave it with. No shortcut, as I think. Zero to 2 pi, integer part, mod sin x plus mod cos x. First, let me remove these inner moduli, breaking the interval as 0 to pi by 2, pi by 2 to pi, pi to 3 pi by 2, and finally 3 pi by 2 to 2 pi. In the first interval, function to be integrated is integer part sin x plus cos x. In the second interval, function to be integrated is integer part sin x minus cos x. In the third interval, it will be integer part minus sin x minus cos x. And in the last interval, it is integer part cos x minus sin x. How to find the integer part of the sum? One approach may be club the two terms. Club them as 0 to pi by 2 integer part root 2 into sin of x plus pi by 4. Next will be pi by 2 to pi integer part root 2 into sin of x minus pi by 4. Next is pi to 3 pi by 2 integer part root 2 into, or let me have it as minus root 2 into sin of x plus pi by 4. And last part is 3 pi by 2 to 2 pi integer part root 2 into cos of cos A cos B minus sin A sin B cos of x plus pi by 4. X is between 0 and pi by 2. X plus pi by 4 will be between pi by 4 and 3 pi by 4. When theta is between pi by 4 and 3 pi by 4, sin theta will be ranging between 1 by root 2 and 1. It starts from 1 by root 2, increases to 1, then decreases to 1 by root 2. Throughout, the values will be between 1 by root 2 and 1. Will they have, the values lie between 1 by root 2 and 1, get it multiplied by root 2. The product will lie between 1 and, this is lying between 1 by root 2 and 1, into root 2 will be lying between 1 and root 2. So, the values will have a common integer part, that common integer part is equal to 1. Integral value pi by 2. X is between pi by 2 and pi. Again, x minus pi by 4 will be between pi by 4 and 3 pi by 4, same as before. Into 2 will be between 1 and root 2. Integer part will have a common value 1, and integral pi minus pi by 2, 1 more pi by 2. X is between pi and 3 pi by 2. X plus pi by 4 will be between 5 pi by 4 and 7 pi by 4. For numbers between 5 pi by 4 and 7 pi by 4, sin theta will be between minus 1 by root 2 and minus 1. At 5 pi by 4, value is minus 1 by root 2. Thereafterwards, it decreases to minus 1, again starts increasing and lands at minus 1 by root 2. In the interval, within the interval, values will be between minus 1 by root 2 minus 1. Agreed? Into minus root 2. Product will be between plus 1 and plus root 2. Integer part, common value 1, same as before. And value of the integral, same as before, another pi by 2. X is between 3 pi by 2, 2 pi. X plus pi by 4 will be between 7 pi by 4 and 9 pi by 4. Cos x will be between 1 and 1 by root 2 into root 2 will be between root 2, 1 and root 2, integer part 1 once again, and value of the integral pi by 2. The sum 2 pi is the value of the required integral. Sometime later, as another property of integrals, definite integrals, we will be noting that for every periodic function, you can obtain the value of a definite integral more easily taking the help of the period. With that, using that property, using that idea, this could have been more easily obtained. Could have been obtained more easily by finding that this is a periodic function with period pi by 2. So, I need find the value of the integral only from 0 to pi by 2, later get it multiplied by how many times intervals of length period are contained in this interval, 4 times, multiplying, we could have got the answer. We will be applying that method later for some other problems. Zero to 1000, integer part tan inverse x dx, one of the simplest problems of this list. What is tan inverse 0? 0. What is tan inverse 1000? Not a well known number, but certainly it is less than pi by 2, because for x equal to infinity, tan inverse x is becoming pi by 2. For every number between 0 and pi by 2, 0 and infinity, tan inverse x will be some number between 0 and pi by 2. Agree. So, here also, even though this upper limit is just 1000, much below infinity, the actual value of tan inverse will be some number between 0 and pi by 2. So, what can be the integer part? Either 0 or 1, only two choices. Where does that change take place? At the point where this is 1. Where is this 1? No. You are supposed to keep quiet. This class is not meant for you. At tan 1. Okay, tan inverse of tan 1 is 1. In the interval 0 to tan 1, tan inverse x will be between tan inverse 0 and tan inverse tan 1, that is 0 and 1, integer part will be 0. I had one more comment to pass, I am controlling myself. In this interval, tan inverse is between 1 and pi by 2, throughout integer part is 1. Whatever be the value of the upper limit, you can go up to infinity. The integrand will remain 1. Next, 0 to n square, n is a natural number, integer part root x. Again, our objective will be to first get rid of this square brackets. For that, we need break the interval of integration. We break it as 0 to 1 plus 1 to 2 square plus 2 square to 3 square. It goes up to until we cover the whole interval. In this interval, root x will be between 0 and 1, integer part will be 0. Now, root x is between 1 and 2, integer part is 1. Now, root x is between 2 and 3, integer part is 2. Now, root x will be between n minus 1 n, integer part n minus 1. Value, this is 0, 1 into 2 square minus 1 square, 2 into 3 square minus 2 square, plus 3 into 4 square minus 3 square, so on, up to n minus 1 into n minus 1 whole square minus n square. reverse, n square minus n minus 1 whole square. Is there any way to simplify this expression? Treating this as a square minus b square, let me write it in a factored form. 1 into 3 into 1. This is 2 into 5 into 1. This will be 3 into 7 into 1. So on. Last term, n minus 1 into 2n minus 1 into 1. Agreed. In short, I may write this as summation. General term, ignoring the last factor which is 1 throughout, is a product of two factors. First factor being 1, 2, 3, general term n or r. Agreed? Second factor 3, 5, 7 form an arithmetic progression with common difference 2. So 2r plus 1. Plus 1 to get the value adjusted. Okay. Values start with r equal to 1 and end at r equal to n minus 1. Final value n minus 1. Expanding 2 into summation r square. Formula summation r square when r ranges from 1 to n is n into n plus 1 into 2n plus 1 by 6. Now r is ranging only up to n minus 1. So value will be n minus 1 into n into 2n minus 1 divided by 6 plus summation r, again r ranging from 1 to n minus 1 only, n minus 1 into n divided by 2. Little bit of simplification. What is common? N into n minus 1 common. Inside 2n minus 1 divided by 3 plus 1. Plus 1 by 2. Agreed? Mod of mod x square plus 1 plus mod x square minus 1. Again, first our aim will be to remove the innermost moduli. This is an expression which is always positive, so modulus is always itself. This expression is an expression vanishing at plus or minus 1. Are both plus or minus 1 interior points of this interval? Yes. We first break the interval of integration at those points, plus 1, minus 1. In the first interval, minus 1 to 2, our integrand will be mod of x square plus 1 itself, mod of x square minus 1 is itself. In the interval minus 1 to 1, mod x square plus 1 is x square plus 1 and mod x square minus 1 is 1 minus x square. In the last interval, once again, mod of x square plus 1 plus x square minus 1. This is mod 2x square, which is same as 2x square. Next is mod 2, which is just 2. Last is mod 2x square, which again simply is 2x square. 2/3 of x cube between minus 2 and minus 1. Minus 1 minus minus 8. 2 into 1 between x between minus 1 and 1 plus 2 by 3 into x cube between 2 and 1. This kind of problem, has it been tried yesterday once? Yes, I think. Yes. This also we must have tried with different numerical values maybe, but both these have been tried once. So our next application will be simple. Integrand is root of sin x into 1 minus sin square x cos square x. It is 0 to pi root sin x into root cos square x. Root cos square x is mod cos x. Mod cos x, to remove this modulus, we notice that cos x is not throughout positive from 0 to pi. It changes sign at pi by 2. So if we break the interval as 0 to pi by 2 and pi by 2 to pi, we will be getting the integrands root sin x in the first interval, root sin x into cos x in the second interval, minus root sin x into cos x. And each is easily obtainable. You know how, using the substitution sin x equal to t or t square. We have to first identify which exactly is the function to be integrated. Let me draw the graph for each one of the three functions: f of x equal to 1, f of x equal to sin x, f of x equal to 1 minus cos x over the interval of integration 0 to pi. First function f of x equal to 1 has a very simple graph. It is a line segment parallel to the x-axis at a height of 1. Second function 2 sin x has value 0 at 0, has value 0 at pi, attains a height of 2 units at pi by 2. From 0 to pi by 2 it is increasing, from pi by 2 to pi it is decreasing, with this height being 2. The last function 1 minus cos x attains the value 0 at 1 at 0, attains the value 1 at pi by 2, attains the value 2 at pi. So from 0 to pi by 2, it is an increasing function with starting value 0, ending value 1. From 1 to pi, further increase, it increases from 1 to 2. And at pi by 2, it will have a change of direction. The direction of bending will be changing. Okay. We are supposed to select the maximum of these three. We find from the graph, we find in this small piece, the maximum of the three is this one. From here to this point, the maximum is this. And to the right of this point, this is the maximum. Change in formula takes place once at this point, second time at this point. What is this point? This is the point where value of the function on this graph attains the value 1. This is the graph for the function 2 sin x. Where does 2 sin x become 1 or sin x equal to half? Pi by 6. The next point where the formula changes is this point. This is the point where 2 sin x and 1 minus cos x cross each other. Value of 2 sin x is same as the value of 1 minus cos x. 2 sin x is equal to 1 minus cos x. When does this take place? You need to find the point where the two expressions 1 minus cos x and 2 sin x attain same value. Or you get 2 sin x plus cos x equal to 1. Or root 5 into sin of x plus alpha is equal to 1, where alpha is a number such that sin alpha equal to 1 by root 5. Sorry, cos alpha is equal to 1 by root 5. Multiplying and dividing by root 5, you get root 5 into 2 by root 5 sin x plus 1 by root 5 cos x. 1 by root 5 cos x plus 2 by root 5 sin x can be identified as sin x plus alpha, where cos alpha will be 2 by root 5. Okay, cos alpha 2 by root 5 and sin alpha 1 by root 5. What I wrote earlier was correct. Sin alpha is equal to 1 by root 5. Cos alpha is 2 by root 5 or tan alpha 1 by 2. Alpha is not a well-known angle. Doesn't matter. It's enough if you know this much information about alpha. What is the x now? X is the number such that sin x plus alpha is equal to 1 by root 5. So what is the x? What is the x coordinate of this point of intersection? Sin inverse 1 by root 5 minus alpha. But sin inverse 1 by root 5, according to my knowledge, is an angle in first quadrant, is an angle between 0 and pi by 2. My alpha is another angle in the first quadrant. Okay, this also is sin inverse 1 by root 5. You are saying x is sin inverse 1 by root 5 minus alpha, but my alpha also is sin inverse 1 by root 5. So it becomes alpha minus alpha equal to 0. But from my figure it is clear, my alpha is not equal to 0. You give due importance to the position of the point. What you are required to calculate is not simple calculation of inverse trigonometric values. What you need find as x here is not simple sin inverse 1 by root 5 minus alpha. This is not sin inverse 1 by root 5. Instead, it is one of the values of sin inverse 1 by root 5, not the principal value, alpha to be subtracted from it. This alpha may be the acute angle such that sin alpha equal to 1 by root 5. This alpha you may describe as sin inverse root 5. But this x plus alpha you cannot describe as sin inverse or 1 by root 5. It is some other angle. It's an angle between pi by 2 and pi for which sin theta is 1 by root 5. Yes. The principal value of sin inverse 1 by root 5 is some number between 0 pi by 2. I want the other value, the next value which lies between pi by 2 and pi. Yes, it is pi minus. Okay, first you give me an expression for this. This will be pi minus sin inverse 1 by root 5. What is sin of pi minus sin inverse 1 by root 5? Sin of pi minus theta is sin theta. So it will be sin of sin inverse 1 by root 5 equal to equal to 1 by root 5. Okay. So my x plus alpha is pi minus sin inverse 1 by root 5, referring to the figure, and therefore my x will be pi minus sin inverse 1 by root 5 minus alpha is 1 more sine inverse 1 by root 5, it will be pi minus 2 sine inverse 1 by root 5. That will be the point where the second break will take place. Okay. My integral becomes therefore 0 to pi by 6. What is the function to be integrated? 1. From pi by 6 to this point, pi minus 2 sine inverse 1 by root 5, the function to be integrated is 2 sine x. Agreed? Last, pi minus 2 sine inverse 1 by 5, 1 by root 5 to pi, the function to be integrated is 1 minus cos x. 5. Once you notice these intervals, later part becomes simple. Integration, first integral value pi by 6, second integral minus 2 cos x to be evaluated between pi by 6 and pi minus 2 sine inverse 1 by 5, 1 by root 5. Last one, x minus sin x to be evaluated between pi minus 2 sine inverse 1 by root 5 and pi. This is pi by 6 minus 2 into, what is cos at upper limit? Cos of pi minus 2 sine inverse 1 by root 5. Cos of pi minus theta is minus cos theta. It will be minus cos of 2 sine inverse 1 by root 5. Agreed? But for any theta, you know, cos 2 theta is obtainable as 1 minus 2 sine square theta. Okay, using that identity, cos of 2 sine inverse 1 by root 5 is 1 minus 2 into sine square sine inverse 1 by root 5. Agree? Using the identity cos 2 theta equal to 1 minus 2 sine square theta. Last part, x evaluated between the limits is 2 sine inverse 1 by root 5 minus sin x evaluated between the limits sin pi 0 minus sin of pi minus 2 sine inverse 1 by root 5. Sin of pi minus theta is sin theta. So, it will be sin of 2 sine inverse 1 by root 5. Sin of 2 theta is 2 sin theta cos theta. It will be 2 into sin theta, sin of sine inverse 1 by root 5, 1 by root 5 into cos theta, cos of sine inverse 1 by root 5, 2 by root 5. How? There are two methods. Knowing sin theta to find cos theta, you have two methods. One method, root of 1 minus sin square theta. Another method, draw a figure. You have sin theta equal to 1 by root 5. So, what will be cos theta? This side will have length 2, cos theta will be 2 by root 5. Agreed? Is the list finished? Yes. Break. Okay. So, for definite integrals, how many properties have been noted now? First property, integral a to b f of x is integral a to b f of t. No change in the name, no importance to the name we assign to the variable. Okay. Next one, integral a to b is minus of integral b to a. Then this itself, integral a to b is integral a to c plus c to b. Okay. Our next property is concerned with a particular type of function. Property you know already. If a function is even, integral from minus a to a will be twice integral 0 to a, because the graph will be symmetric about y axis, and if a function is odd, because the graph is symmetric about origin, integral from minus a to a for any a will be equal to 0. When is a function said to be even? F of minus x equal to f of x, and odd if? Are there functions which are neither even nor odd? Yes, there are many. Is there any function which is both even and odd? Yes, one function. The constant function which attains the value 0 at every point. Not a very constant function. The only constant function f of x equal to 0 for every x. That function is both even and odd. That's the only function which is both even and odd. All other functions are either even or odd or neither. What about this function? Even or odd or neither? Even. 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 Odd. Neither even nor odd. Odd. Why? Is even. Neither even nor odd. What is log of minus x? Is it minus of log x? Even. Neither even nor odd. Neither even nor odd. Even. Because the function is odd. Denominator is an even function, numerator is an odd function, odd divided by even is odd. Odd into odd is? F is a function which is odd. F of minus x is minus f of x. G is another odd function. G of minus x is minus g of x. What can you say about fg? Fg of minus x. F of minus x into g of minus x. Even. Odd into odd is even. Odd into even is odd. Even into odd is? Even into even is? Even plus even is? Even plus odd is? Neither. Neither. Odd plus odd is? Odd. This is an odd function. Numerator odd, denominator even, quotient is an odd function, integral value 0. 0, because the integrand is an odd function. You replace x by minus x, integrand becomes log of 1 minus x by 1 plus x, which is negative of log 1 plus x by 1 minus x. This is odd, this is even, this is odd, the product becomes even, this is another odd function, the product remains odd, and therefore integral from minus pi by 2 to pi by 2 is 0. This is an even function, this index being even is an even function, this is an odd function, the product is an odd function, integral value is 0. One second. Are there any points where the denominator vanishes? Yes. Where is the denominator 0? X equal to plus or minus 1 by root 2. Are those points interior points of this interval? 1 by root 2 and plus minus 1 by root 2 and plus 1 by root 2. Okay, let me avoid those points belonging to the interval so that the integrand remains meaningful throughout the interval of integration. Now there is no problem. We find that the function to be integrated is neither even nor odd, but we can break it, we can decompose it, so that one part contains only odd terms and another part contains only even functions. We can write it as 2x cube minus 5x divided by 2x square plus 1, it will be an odd function, plus 3x square plus 1 divided by 2x square plus 1, which is an even function. For the odd part, integral from minus 1 to 1 is 0, so the only remaining part will be minus 1 to 1 3x square plus 1 by 2x square plus 1 dx. This being an even function will have its integral from minus 1 to 1 equal to 0 to 1, and to carry out the integration process, let me simplify the integrand. Let me write it as 3 by 2 plus, I am trying to divide. My fraction is an improper fraction. I am trying to get it as a polynomial plus a proper fraction. The polynomial part will have only one term because degrees are equal. That term will be 3 by 2. The other part, proper fraction part, will be minus ನಂಗೆ ಗೊತ್ತಿಲ್ಲ, ನೀವೇ ಹೇಳಬೇಕು. ಮೈನಸ್ ಹಾಫ್. ಓಕೆ, okay, and this is equal to twice 3 by 2 is 3 into integral 1 dx from 0 to 1 is 1 minus 2 into half 1 into dx integral dx by 2x square plus 1 from 0 to 1. How to carry out the integration of 1 by 2x square plus 1? Use of formula for integral of 1 by x square plus a square. Before applying that formula, we may reduce the x square coefficient to 1. Simplicity sake, 3 minus half of. Now the integrand becomes 1 by x square plus half, 1 by x square plus a square, integral of which is 1 by a tan inverse x by a. Here it becomes 1 by a is 1 by root 2, tan inverse x by a is 1 by root 2. Limits 0 and 1. Tan inverse root 2 minus tan inverse 0, tan inverse 0, 0, tan inverse root 2 remains. Is this a well-known angle? No, I think. So, we will keep the value as it is. Again, we find the integrand being composed of two parts. Part 1 sin power 10x into cos x, which is even, and part 2 tan power 13x into cos x, which is odd. Using the property integral of an odd function from minus a to a equals 0, we find our required integral is simply minus pi by 2 to pi by 2 sin power 10x cos x dx. And you know how to get this integrated. More problems later. For the present, this much enough. Next property, another highly useful property. For any function f of x and any two numbers a and b chosen as limits, integral a to b f of x dx is also equal to integral a to b f of a plus b minus x dx. In particular, if lower limit is 0, upper limit is a, integral 0 to a f of x dx may also be obtained as integral 0 to a f of a minus x dx. This is the general version, this is the particular version. Both are equally useful in many numerical problems. Are you already familiar with this situation? No. No need. Simply apply this property. 0 to a f of x dx is 0 to a f of a minus x dx. So, this integral is also equal to 0 to pi by 2 sin of pi by 2 minus x cos x by sin of pi by 2 minus x cos x plus cos of pi by 2 minus x sin x. What are you getting? This is equal to integral from 0 to pi by 2 cos x by sin x plus cos x dx. I is equal to I1, also equal to I2, must be equal to half of I1 plus I2. What is I1 plus I2? Pi by 2. So, I value pi by 4. Is it not clear? Pi by 4. Pi by 4. Pi by 4. Okay. Write tan as sin by cos. Get it slightly simplified as cos power 10 by 3 by sin power 10 by 3 plus cos power 10 by 3. What is the value? Pi by 2. Pi by 4. Pi by 4. Limits are 0 and pi, not pi by 2 now. And the function is sin x by 2 by sin x by 2 plus cos x by 2. Suppose you apply the property as before. Integral will be equal to 0 to pi sin of half of pi minus x. Pi by 2 minus x by 2. What is sin of pi by 2 minus x by 2? Cos x by 2. By cos x by 2 plus cos of pi by 2 minus x by 2. Sin x by 2. What is that you are observing? Our given integral is I. I is also equal to integral 0 to pi cos x by 2 divided by sin x by 2 plus cos x by 2 dx. If I is equal to I1 also equal to I2, it must also be equal to I1 plus I2 divided by 2. What is I1 plus I2? Integral 0 to pi of 1. Pi. Therefore, what is value of I? Half of that. Or one other method may be, you know, value is easily computable if lower limit is 0, upper limit is pi by 2. How to get this upper limit changed to pi by 2? Use of a substitution. New variable must have value pi by 2 when x equal to pi. So your new variable will be defined as x by 2. You use the substitution t equal to x by 2. Then lower limit will remain 0, upper limit will become pi by 2. Integrand will become sin t by sin t plus cos t. With an additional constant factor, dx will be twice dt. Some 2, one constant factor 2 will appear there. So it will be twice this integral. This is pi by 4. Twice that value of this integral will be pi by 2. That way also you can obtain it. Same problem, one more version. You can solve it in two ways, either using x by 20 equal to t or directly applying the property. Apply the property, what do you get? Integral is also equal to 0 to 10 pi of sin of 1 by 20 into 10 pi minus x. What is 10 pi minus x divided by 20? It is pi by 2 minus x by 20. What is sin of pi by 2 minus x by 20? Cos x by 20. Cos x by 20, sin x by 20. You are finding I equal to I1 also equal to I2. Therefore, must also be equal to half of I1 plus I2. What is I1 plus I2? 10 pi. Half of that, 5 pi is the value of this integral. One more situation where this property is of great help is without the property. What is your method for carrying out this integration? You will have to expand this 1 minus x to the power 101. You will get just 102 terms. Multiply each term by x. Carry out term by term integration. Apply the limit. Simplify. Answer is obtained. Very simple exercise. But with the help of the property, you have an alternate method. What do you obtain? If you apply the property 0 to a f of x dx equal to 0 to a f of a minus x dx. The property just says leave the limits unchanged in the integrand, only in the integrand, not even in dx. Replace x by a minus x. Replace x by 1 minus x. What will happen to the integrand? 1 minus x into 1 minus 1 minus x remove brackets, carry out term by term integration, apply limits. One more situation of the same kind. My point is, you need not have to make use of this idea. You need not have the upper limit 1, it may be any number. But if the upper limit is some a, this factor must be a minus x. If the upper limit is 1, you should have this equal to 1 minus x. If this is 2 minus x or something else, property will not be of that use. So, if this is 5 minus x, you can make use of the property, get this index shifted to this position, and expansion becomes much simple. One more situation where you have to depend on the property that we were discussing. As it is, it looks like a very difficult integration problem. The reason, the integrand is a mixture of algebraic and trigonometric. If this x were not there, integration would have been a very simple problem. If this sin x cos power 6x part is not there, integration very simple. Now you have a mixture, you have algebraic as well as trigonometric. Integration will not be an easy process. But if you apply the property, what happens is, leave the limits unchanged. In the integrand, only in the integrand, throughout, replace x by upper limit minus x, pi minus x. What is sin of pi minus x? Sin x. What is cos of pi minus x? You need not give any importance to the sign. Index is even. Whether it is minus cos x or plus cos x, immaterial. Power 6 will be same. Agreed? Yes. I is equal to this much, is also equal to this. Suppose you add these two, what do you get? Call this I1, call this I2. What is half of I1 plus I2? Because limits are same, as it is you can add the integrands. When you sum the integrands, you will be getting this part x sin x cos power 6x cancels against minus x sin 6x cos power 6x, leaving just pi into sin x cos power 6x dx. Now, you have got rid of that algebraic factor. Integration has turned out to be a very simple exercise. Use of substitution, cos x equal to t minus sin x dx dt, carry out the process. One more case where the integrand is a mixture of varieties, two varieties of functions. In this case, one is a trigonometric function, another is an exponential function. When you have the integrand as a mixture of different kinds of functions like this, direct integration will be difficult. But if you apply the property, before applying, going for applying that property, shall I make use of even odd? Is my integrand even or odd? No, it is neither even nor odd, is it not? So, there is no hope of making use of that property. Even though the limits are minus a and a, I am not in a position of taking the advantage of that property. Okay, let me depend on the current property, the property that I was discussing. Integral a to b f of x dx is integral a to b f of a plus b minus x dx. Lower limit is not 0. Therefore, you cannot use the simpler version 0 to a equal to f of a minus x. Use the earlier general version a to b equal to f of a plus b minus x. What is a plus b minus x? Simply minus x. What is cos square of minus x? Cos square x by 1 plus 13 to the power minus x dx. Do not confuse this with the substitution. You are not using substitution x equal to minus d. You are just using the property. So there will be no effect on the differential. Only the integrand gets changed. Okay. This is simplified. This is minus pi to pi of 13 to the power x into cos square x divided by 13 to the power x plus 1 dx. You notice given I is also equal to this. Suppose you add these two, what do you get? Therefore, I is also equal to half of this plus this. What is this plus this? Limits are equal. So, as it is, you can add the integrands. What will be the sum of the integrands? Cos square x. Again, integrand is not a simple function, it is a mixture of varieties of functions. One part trigonometric, another part trigonometric. This is logarithm of a trigonometric function. Because of the presence of this log, it looks like a difficult integration exercise. But if you take the help of the property, the process becomes simple. Integral is having lower limit 0, so you can use the simpler version. Integral 0 to a equal to 0 to a f of a minus x dx. What is cos square of 2 into pi by 2 minus x? Cos square 2x. What is sin to the power of 4 into pi by 2 minus x? Is sin to the power 4, 4x. What is tan of pi by 2 minus x? Cot x. Now immediately we observe this log cot x is expressible as log of tan x power minus 1. It's simply minus log tan x. Therefore, what we have obtained here is minus I. I is equal to minus I means I is equal to 0. ಆ ಸಿಚುವೇಶನ್ಸ್ ಎಲ್ಲ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಇಂಥ ಪ್ರಾಬ್ಲಮ್ ಎಲ್ಲಿಯಾದರೂ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ನಲ್ಲಿ ಬಂದರೆ ಬೇರೆ ಏನೂ ಥಿಂಕ್ ಮಾಡದೆ ಡೈರೆಕ್ಟ್ ಯು ಶುಡ್ ಪ್ರೊಸೀಡ್ ಟು ಅಪ್ಲೈ ದ ಪ್ರಾಪರ್ಟಿ, ಗೆಟ್ ದ ಆನ್ಸರ್ ಇಮಿಡಿಯೇಟ್ಲಿ. ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿ ಸರಿಯಾಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಬೇಕು. First, let me bring the integral to a simpler form through a substitution. What substitution may help us? The presence of 1 plus x square hints us to use the substitution x equal to tan theta. What is the advantage? This 1 plus x square will be 1 plus tan square theta equal to secant square theta. This dx also will have a factor secant square theta. You will be able to remove that as a common factor. You will be left with d theta by 1 plus tan cube theta with the new limits. when x equal to 0, theta equals 0. When x equal to infinity, theta equal to pi by 2. And now you notice that your problem is a very simple problem with the value of the integral equal to how? Sine cube by cos cube. Shift cos cube to numerator. Cos cube by sine cube plus cos cube. We had discussed that situation earlier. Value is half of pi by 2 pi by 2. Next property. Suppose your function satisfies the property f of minus x equal to f of x or f of minus x equal to minus f of x. You will have the function either even or odd. You have a very useful property, you can apply it. But most of our functions are neither even nor odd. In such cases, to apply one more situation of the same kind. Suppose you find f of 2a minus x equal to f of x, where a is the upper limit. If zero to 2a f of x dx equal to twice 0 to a f of x dx, provided f possesses the property f of 2a minus x equal to f of x for every x. For example, is f of 2a minus x equal to f of x? Is cos of 2 pi minus x equal to cos of x? Yes, the property applies. What do you get? It's equal to twice 0 to pi cos to the power 5x dx. Agreed. It's a very simple integral whose value is 0. How? F of x is cos power 5x. What will be f of 2a minus x? F of 2 pi minus x is cos power 5 of 2 pi minus x. Is it not exactly cos power 5x? Yes, property applies. We will be able to write it as twice 0 to pi cos power 5x, and the value is 0. How? Question of odd even does not arise, because the limits are not minus a and a, limits are 0 and pi. And further, this function is not odd, this is an even function. So, not one mistake, two mistakes. It is 0, value is 0. How? Use of the property 0 to a f of x equal to 0 to a f of a minus x. This, if you call this I, your I is also equal to 0 to pi cos power 5 of pi minus x dx. What is cos of pi minus x? Minus cos x. What is cos power 5 of pi minus x? Minus of cos power 5x. So, what you are observing? I is equal to minus I. I equal to minus I means I must be equal to 0. Next, a property applicable in the integration of periodic functions. Suppose the integrand is a periodic function with period t. The property is based on geometric interpretation. A graph is periodic with period t means what? If you draw the graph, if you draw a sketch for the function, the graph will have repeated occurrence of same part. Say one part of the graph will be repeatedly occurring over intervals of length t again and again. For example, in the case of sine, you have the graph between 0 to pi as this. When you continue with higher values for x or lower values for x, same curve will be again and again recurring. Therefore, if you are asked to find the area contained by the curve between two limits, the limits containing this interval several times, then evaluation of the integral becomes easy once you notice that the graph is periodic, function is periodic. Suppose your interval length is say 0 to 4 pi. You find that same area is repeatedly occurring twice. You need carry out integration from 0 to 2 pi and get it multiplied by 2. Suppose you want the integral from 0 to 6 pi. Just compute this, get it multiplied by 3. That idea is mentioned here. Suppose you are required to integrate from 0 to nt, an interval containing an interval of length t n times. Period length interval is repeated n times. Then value of the integral will be n times integral carried over any one piece of length t. Any one piece. You need not have it from 0 to t. You can have it from t to 2t also. You can have it from 3t to 4t also. You can have it anywhere. But the length of the interval must remain t. You can also have it as minus t by 2 to t by 2. No problem. Okay. You consider any one interval of length t, evaluate the integral over that interval, multiply it by the number of times the interval is recurring in this interval of integration, you get your answer. Your starting point need not be equal to 0, it may be something else also. It may be any number like a plus nt. And ending point also may be any number like b plus mt. Or to begin with, let me have same nt. Will be equal to, can you guess? Your starting point is some point plus, in this case period is 2 pi. Say 2 pi. You start from this point. This is this length plus 2 pi. And that some other point which is of the form b plus 2t. Say this is this length plus 2 pi. So you are asked to integrate from here to here. Is it equivalent to integrating from here to this point? You are required to obtain the area covered between these two lines. Those two lines can be traced here also, can be traced somewhere here also, anywhere you can trace. Just to note where the interval begins and where the interval ends. Take care to see that. Once you mark that, you will be able to find the area. This area may be identified with A to B. One more version. Suppose you are integrating from nt to mt. Your starting point is not 0 as you had here. It is some other multiple of t. To some another multiple of t, you are carrying out integration. And it will be simply number of times the interval is covered into integration carried over any one interval of length t. You can have any point as starting point, but the length of the interval of integration must be 1t. It may be 0 to t, maybe minus t by 2 to t by 2, maybe 5t to 6t, anything you like. Okay. This is true for all mn belonging to I. Integral m and n. ಬೇಡ ತಿರುಗಿಸಿದ್ರಲ್ಲ ಬೇಡ. Okay, some examples to illustrate the idea. Is the integrand a periodic function? Yes. What is its period? 1 second. Is this a periodic function? Yes. What is the period? 2 pi. Is this also a periodic function? What is the period? 2 pi. Primitive period I am meaning. Okay. Is this also a periodic function? Yes. Period? Pi. Now the period will be pi. Now the period is pi. Cos power 4 of pi minus x. Is it not same as cos power 4 of x? Cos of pi minus x may be minus cos x. But when you raise both sides to a even power, will not the two sides be equal? Yes. Now the period will be 2 pi. No reduction. Now the period is pi. Agree? 2 pi. 2 pi. Pi. No reduction. It remains as pi only. Pi. For any index, it will continue to remain as pi. Okay. Pi. 2 pi by 3. 2 pi by k. 1 pi by k. Pi by k. 2 pi by k. Pi by k. Two pi by 5. Pi by 5. Pi by 5. 2 pi by 5. Pi by 3. For tan x period is pi, now pi by 3. Pi by 13. No reduction, further reduction. Pi by 13. Is this also a periodic function? Yes. Yes or no? No. What is the graph? Is this periodic? No. Periodic? Yes. What is the period? Period? Primitive period. 1. 1. Half. 1 by 3. 1 by k. Not periodic. From 0 to 1, you will have one value. From 1 to root 2, another value. Root 2 to root 3, third value. Root 3 to 2, fourth value. Not periodic. So, is sin square 2x periodic? Yes. What is the period? Yes, yes. Pi or pi by 2 or 2 pi? Pi. For sin x period is 2 pi. For sin 2x period is pi. Index is even. Will there be further reduction in the period? If you want to try pi by 2, what happens? What is sin square of 2 into pi by 2 minus x? Is it same as sin square 2x? Just check, what is that? 2 into pi by 2 minus 2x is pi minus 2x. What is sin of pi minus 2x? Sin 2x square is sin square 2x. Will it not be same as this? Yes. So, this is a function with the primitive period, not 2 pi or pi, is further smaller, it is pi by 2. Okay. How many intervals of length pi by 2 are contained here? Total width of the interval is 25 pi minus 15 pi, 10 pi. How many intervals of length pi by 2 are contained there? 20. 20 times integral of sine square 2x over any continuous interval of length pi by 2. Any interval of length pi by 2 you may choose. According to your convenience, you may choose minus pi by 4 to pi by 4. You may choose 0 to pi by 2. You may choose 5 pi by 2 to 6 pi by 2. Anything you can choose. Which you prefer? 0 to pi by 2. How to integrate? Take 1, 2 inside. Write the 2 sin square 2x inside as 1 minus cos 4x. Get it integrated between the limits 0, pi by 2. First term of the integral will be 10 into integral 1 dx, 10 into pi by 2, 5 pi. Second term, 10 into integral minus cos 4x. Is it sin 4x? Minus sin 4x, whatever it be. At the limit 0 and pi by 2, that sin 4x vanishes. At each of the endpoints of the interval, the function that you are getting after integration vanishes. Therefore, value of the second part is 0. What you are required to obtain is just this much. Correct, Allah? Yes. Suppose this is 3. What will be the answer then? Now our integrand will not be a periodic function of period pi by 2. It will be a function of greater period. What will be the new period now? Will it be pi by 2 now also? No. Okay, sine of 2 into pi by 2 minus x is sine of pi minus 2x. It is sine 2x, not minus of sine 2x. Therefore, cube also will be the same. And therefore, you get 20 times integral sine cube 2x to be evaluated over any interval of length pi by 2. You may take 0 to pi by 2 or pi by 2 to pi or 3 pi by 2 to 2 pi, anyone, which is most convenient to you. 0 to pi by 2. I find minus pi by, this is 3, is it not? Cube. I find minus pi by 4 to pi by 4 may be more advantageous. Is not my integrand an odd function? Yes or no? Yes. Agreed, I think. ಏನು ಹೇಳಿ? Yes, yes. Yes. While checking periodicity, yes, what you have to check is, we have to find f of x plus t, not x minus t or t minus x. We have to check whether these are equal or unequal. In this case, it will be sine of 2 into pi by 2 plus x, not minus x. Throughout we were considering pi by 2 minus x. No, that was wrong. This will be pi plus 2x, and sine of pi plus 2x is minus sine 2x. If the index is even, no problem. Or previous work, no problem. Now for this present function, period is not pi by 2, it is just pi. Therefore, I will have to write it as not 20 into 10 into integration to be performed over any interval of length 1 pi. I prefer to have that interval as minus pi by 2 to pi by 2. In the final answer you have obtained, there is no alteration, no change. But in the process, some mistakes were committed, serious mistakes were committed. Good. Is our integrand a periodic function? Yes. What is its period? Primitive period 1. How many intervals of length 1 are contained in our interval of integration? 30. 30 times integral fractional part x dx over any interval of length 1. Which interval you prefer now? 0 to 1. In the interval 0 to 1, for any x belonging to the interval, what is the fractional part? Suppose you had, instead of fractional part x here, you had fractional part x by 2. What will be the change? This now is not a function with primitive period 1. Instead, the primitive period will be 2. Therefore, our right hand side will be not 30 times, instead it will be just 15 times integration to be performed over some interval of length 2. You may take 0 to 2 or minus 1 to 1. You prefer, your choice 0 to 2. Okay. It is 15 times 0 to 2 of, when x is between 0 to 2, x by 2 will be between 0 and 1. So, the fractional part will be x by 2. Again, is the integrand a periodic function? Yes. What is the period? Pi. 1 pi. Okay. Pi or 2 pi? Odd power, therefore 2 pi, not 1 pi, it is 2 pi. Okay. So, how do you break this interval? Now, our interval is not an integral multiple of the primitive period of the function. It is an integral multiple plus another fractional multiple. Keep that fractional multiple separate. So, one interval of length 1 pi I will be keeping separate. You can keep it separate at the beginning or at the end, somewhere. Anywhere you choose one interval of length pi and separate it. Remaining will be 1 pi to 101 pi sine cube x dx. That 1 pi to 101 pi is an interval of length 100 pi, which is an integral multiple of the primitive period of the function. It is 50 times the primitive period. So, I may write it as 50 times integral sine cube x dx evaluated over any interval of length 2 pi. Your choice, minus pi to pi. Why? This is an odd function. This is 0. How about this? Several methods are there. One method, use of formula for sin 3 theta. Another method, sin square x into sin x. 1 minus cos square into sin. Use of substitution, cos x equal to t. I am writing it as cos square x into 1 minus cos square x into sin x using the substitution cos x equal to t. So, it becomes 1 minus t square into minus dt. New limits, cos 0, cos pi. Interchange the limits, get rid of this negative sign. The integral becomes minus 1 to 1, 1 minus t square dt. Integral t from minus 1 to 1 is 2 minus t cube by 3 between minus and 1 is Agree? Again, the interval of integration does not contain an integral number of times intervals of length t, where t is the period of the function. Period of the function, as before, is 2t. This interval is not an interval which has length equal to an integer times the period of the function 2 pi. So what should we do? We have to split it into two parts. Keep the part which objects us in recognizing the interval as a integral multiple of interval of length t. Keep that part separate, and this part, which is an integral multiple, you keep that separate. In that second part, apply the property, corresponding property. What do I get? What is the length of the interval? 21 pi by 4 minus pi by 2. 21 pi by 4 minus 2 pi by 4. 19 pi by 4. Suppose you had one more interval of length pi by 4, it would have been, no, even then, length plus pi by 4 means 20 pi by 4 means 5 pi. Even then it will not be an integral multiple of 2 pi. Okay, let me not think in that direction, negative direction. Let me remove one portion from this and retain a portion which is an interval of length equal to an integer times 2 pi. What portion must be kept outside? 3 pi by 4. We will keep it from the, we will select an interval of length 3 pi by 4 at the beginning or at the end. Anywhere you can choose. We will choose from beginning. Pi by 2 to pi by 2 plus 3 pi by 4. 5 pi by 4. Function to be integrated sin cube x. Next will be 5 pi by 4 to 21 pi by 4. 5 pi by 4 to 21 pi by 4 means it's an interval of length 16 pi by 4 or 4 pi. Hello, correct? Hello. This length is equal to twice the period of the function. So we may write it as 2 times integral sin cube x dx, integration performed over any interval of length 2 pi, minus pi to pi. Usual method. Cos pi by 2. Cos 5 pi by 4 minus 1 by root. Huh? Huh. ಅಲ್ಲ, ಪ್ರಿಮಿಟಿವ್ ತಗೊಳ್ಳೋದು ಬೆಟರ್ ಅಲ್ವಾ? ಶಾರ್ಟೆಸ್ಟ್ ಪಾಸಿಬಲ್ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಟಿ ಇಸ್ ಬೆಟರ್ ಅಲ್ವಾ ಟು ಯೂಸ್, ದೊಡ್ಡ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಳೋದಕ್ಕಿಂತ. ಈವನ್ 4 pi is a period. You can work taking 4 pi as period also. But from the computational point of view, this is better. A smallest possible value for t is better. ಪೀರಿಯಡ್ 5/2 ಇದ್ದಾಗ ನೀವು 2 pi ತಗೊಂಡು ವರ್ಕ್ ಮಾಡಿದರೆ ಮಿಸ್ಟೇಕ್ ಆಗೋದಿಲ್ಲ. ಎಸ್, ಆಗೋದಿಲ್ಲ, ಕರೆಕ್ಟ್, ಐ ಅಗ್ರಿ. ಬಟ್ ಕಂಪ್ಯೂಟೇಷನ್ ದೃಷ್ಟಿಯಿಂದ 5/2 ತಗೊಳ್ಳೋದು ಬೆಟರ್. ಆರ್ ಪೈ ಇದ್ದರೆ ಪೈ ತಗೊಳ್ಳೋದು ಬೆಟರ್. 2 pi ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಸೈನ್ ಕಾಸ್ ಟ್ಯಾನ್ ಯಾವುದಿದ್ರು 2 pi ತಗೊಂಡು ವರ್ಕ್ ಮಾಡೋದು ಸೇಫೆಸ್ಟ್. ಬಟ್ ಅದರಿಂದ ನಿಮಗೇನು ಅಡ್ವಾಂಟೇಜ್ ಆಗೋದಿಲ್ಲ. ಇಲ್ಲ, ನಿಮಗೆ ಅಡ್ವಾಂಟೇಜ್ ಆಗೋದಿಲ್ಲ. ನೀವು ವರ್ಕ್ ಮಾಡಿ ನೋಡಿ ಗೊತ್ತಾಗ್ತದೆ. ನೀವು 0 to 100π ಮಾಡೋದು ಒಂದೇ, 2π to 50π ಮಾಡೋದು ಒಂದೇ, ಸೇಮ್ ಥಿಂಗ್ ಇಟ್ ವಿಲ್. ಬೇಕಾಗಿಲ್ಲ. This is P plus NA, Q plus NA. Same multiple of T is added to Q, added to P, added to Q. Our case is, one second. Yes. Our case is pi by 2 plus 0 and 5π by 4 plus 4π. Ours is not pi by 2 plus 4π to 5π by 4 plus 4π. That property says if you have lower limit a plus nt, b plus same nt, not mt, then that property applies, not in this case. In this particular example, because this is an odd function, we are getting 0. Suppose the index is 4, this will have a non-zero value. You cannot neglect that. Which problem is over? 0 to pi by 2 to 21π by 4. Okay. Not 10 into 5, 10.5. This is 23.1. Function to be integrated, fractional part x. Yes. Our interval starts at minus 10.5 and set 23.1. The total length is 23.1 minus 10.5 is 33.6. It's not an integral multiple of the primitive period of this function, which is 1. There is a fractional part also. Keep that interval of fractional part length outside. Okay, what do we do? Let us separate the interval of integration as minus 10.5 to, what is the fraction part here? 0.6. An interval of length 0.6. This plus 0.6. Add 0.6 to this. Minus 9.9. Let us keep this interval separate. Remaining portion will be minus 9.9 to 23.1 fractional part dx. This will be an interval of length equal to an integer, which is an integral multiple of the period of this function. Okay. The second part, integral over an interval of length 23.1 minus 9.9 is 23.1 plus 9.9 is 33. So the integral may be written as 33 times integral of fractional part x dx carried over any interval of length 1. Which interval you choose? 0 to 1. Advantage, in this interval fractional part x is simply x. It remains to find out this integral. This starts at minus 10.5 and set minus 9.9 is not an arbitrary interval of length 0.6. You cannot replace it by interval 0 to 0.6. You cannot replace it by interval 0.4 to 1. It's not to be arbitrarily replaced. Notice that it starts at minus 10.5 and ends at minus 9.9. To have a better replacement, I add an integer to this and try to make it positive. What is the smallest integer which makes this, which when added to this converts this into a positive number? 11 you add. 11 you add to both the limits. Then lower limit will become 0.5 and upper limit will be 1.1. But fractional part takes a break at every integer point. So this integral from 0.5 to 1.5, for sake of convenience of calculation, will be broken into two pieces. 0.5 to 0.1 plus, 0.5 to 1 plus 1 to 1.1. In this interval, the fractional part is simply x, and in this interval, it is x minus 1. Rest is simple. ಇಲ್ಲಿ ಇದೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ನಿಮ್ಮ when the interval length is less than the period of the function, starting point ಮತ್ತು ending point, they are important. ಅಂದರೆ ನೀವು ತಗೊಳ್ಳೋ piece might have been chosen at the middle of the interval. Suppose a function is periodic like this. If you are choosing this portion, it is simple to calculate. Choosing this portion may be easy, but the portion chosen is this. This cannot be replaced by this portion or this portion. Will have to be calculated here only. If you want, you can get it shifted to this place or this place. That is what we did here, adding an integer, which is an integral multiple of the period of the function. Just one more example to illustrate the usefulness of the property we are discussing. Is not your integrand simply 3 to the power fractional part x? That is the important thing that you have to notice. This is a periodic function with period 1. Therefore, this also will be a periodic function with period 1. Therefore, the integral is expressible as 23 minus 11, 34 times integral of 3 to the power x dx to be integrated from 0 to 1. Okay, next few properties help us in obtaining some upper bounds for values of the definite integral. They do not help us in accurately evaluating the integral, help us only in obtaining some upper bounds. In one case, the entire integral is between modulus sign. In the other case, only the integral is inside the modulus sign. Which of the two will be greater? Need not be equal to each other. Only when fx graph lies completely above the x-axis, the two will be equal to each other. Otherwise, they need not be. In general, some inequality connects the two. Some one of the two will be greater than the other. Which one will be greater? Which one will be less? Imagine the graph. Imagine a graph for f of x. Apply modulus to it. What will happen to the area covered by the graph and the x-axis? And in this case, you are first finding the area and then applying modulus. In which case you will be getting a greater number. Second one. So inequality is Less than or equal to or greater? Less than or equal to. And holds for every function f of x. What we have written here is only a particular case of the second line. F and g are any two functions such that graph of g lies above graph of f lies above the x-axis. At least over this interval, graph of f lies wholly above the x-axis, graph of g lies further above that. Which area will be greater? Area covered by graph of g or graph of f? Certainly the graph g covers greater area than the graph of f. Consider the interval 0 to pi by 2. I claim, agree? For any x belonging to my interval, sin x is either 1 or a positive fraction. If it is 1, whether you raise it to power 50 or any integral number, value will remain the same. If it is a fraction, when you raise it to higher and higher powers, value goes on reducing. Therefore, value obtained by raising it to a higher power is less than or equal to this with power 1. And this further is less than or equal to x. Agree? You have an explanation for this? You know why sin x is less than or equal to x? Okay. Because of this, I will have 0 to pi by 2 sin power 50x by x dx is less than or equal to 0 to pi by 2 sin x by x dx, and this further is less than or equal to 0 to pi by 2 x by x dx, which is simply pi by 2. It may be impossible to find this integral in terms of elementary functions, but you can be sure that the value cannot exceed pi by 2. What is expansion of sin x? Are you not getting alternately positive and negative signs? How can you use it to claim that it is less than x?
First term is x. Other terms will have minus, plus, minus.
Yes,
Plus,
alternately minus and plus.
There is a minus sign.
Yes.
And there is a minus sign in the first term. That will be x cube by 3 factorial. Next term will be x power 5 by 5 factorial.
Right.
The value has decreased.
Yes.
So x cube by 3 factorial
Value has
decreased.
How do you know that? Just because denominator has increased, your x may be greater than 1.
X power 5 by 5.
Suppose x is 2, which is greater, x cube or x power 5?
No, sir, by 5 factorial is also.
Maybe that. Compare x cube by 3 factorial and x power 5 by 5 factorial. Take x equal to 100, which is greater. Okay. For higher values, there is no confusion involved, because for any x, sin x is a number between -1 and 1. If x is greater than 1, there is no confusion in claiming that sin x is less than x. Agree? So, there is some doubt only when x is a number less than 1 in numerical value. Then as index increases, power value decreases, and denominator also increases, value further decreases. So what are you claiming? No, not that easily. You must give a better explanation. What is that you are having? Is this the expansion? Is this the expansion? Yes. What you do is, you enclose these two in a pair of brackets. Claim that this is a positive number. Minus. Enclose the next two in a pair of brackets. Claim that this is another positive number. So, throughout you are subtracting. And subtracting nowhere negative number. Throughout you are subtracting positive quantities. Therefore, it will be certainly less than this x. Or a simple geometric explanation. Must be knowing this. This is sin x, this is x, and this tangent length is tan x. This you have used in proving that limit sin theta by theta, theta tends to 0 is equal to 1. Where are we now? Yes. So, this is an integral which cannot be obtained in terms of elementary functions, but with the help of the property I can claim, I may not be in a position to find the accurate exact value, but this much information I can give, it is certainly less than or equal to pi by 2. So, if you are asked to find the integer part of the value of this integral, you can be definite that it must be less than or equal to 1. What is integer part for pi by 2? 1. So, this integer part must be either 0 or 1, can never be any other number. Integer part of this. You may not be knowing the exact value, but some information can also always be given. ಎಷ್ಟಾಯಿತು ಟೈಮ್? ಸಾಕ ಇವತ್ತಿಗೆ? ತಡೀರಿ 1 ಮಿನಿಟ್, ಒಂದು ಸ್ಟೇಜಿಗೆ ತಂದು ಸ್ಟಾಪ್ ಮಾಡ್ತೇನೆ. ಓಕೆ, 2 more examples to illustrate the same property. With that we close. Another integration which cannot be performed in terms of elementary functions, but you can be certain that this is less than or equal to integral 1 to infinity mod of sin x by x square dx. Agree. But let me have a power for sin x. No need. Okay, only this much, it's fine. And for any two functions f and g, you know mod of f into g is mod f into mod g, mod of f by g is mod f by mod g. So, this may be replaced by, this is equal to 1 to infinity mod sin x by mod x square. Mod x square, I need not put modulus, simply x square dx. Over any interval, maximum value sin x can have is 1 and minimum value minus 1. Therefore, mod sin x always will be between minus 1 and 0 and 1, 0 and 1. Therefore, this certainly is less than or equal to integral from 1 to infinity of 1 by x square dx, and this is easily obtainable. Apply the limits. 0 to infinity, sorry. Yes. ಅದು 0 to infinity, 1 to infinity. Sorry, ಅದು 0 ಅಲ್ಲ, ಅದು by mistake I copied it as 0, it must be 1. ಅದು 0 ಆದರೆ, this point, at that point, this function will be undefined. This will be 0 by 0. I must exclude that point from the interval of integration. There is no point in including 0. ಬರೇ ಡಿನಾಮಿನೇಟರ್ 0 ಆದರೂ ಅಡ್ಡಿಲ್ಲ, ಎಂಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇನ್ಫಿನಿಟಿ ಆಗ್ತದೆ, ಅಡ್ಡಿಲ್ಲ ಹೇಳ್ಬೋದು. tan x ಇಂಟಗ್ರೇಟ್ ಮಾಡ್ತೇವೆ, pi by 2 ನಲ್ಲಿ tan x ಇನ್ಫಿನಿಟಿ ಆಗ್ತದೆ, ಅಡ್ಡಿಲ್ಲ. ಬಟ್ ಇದು 0 by 0 ಆಗ್ತದೆ. It should not happen. Not for our convenience. It was an error. Yes. 1. So, exact value not known, but you are sure that value cannot exceed 1. ಅಕಸ್ಮಾತ್ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ನಲ್ಲಿ ಇದರ ಇಂಟಿಜರ್ ಪಾರ್ಟ್ ಎಷ್ಟು ಕೇಳಿದರೆ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಸೇ ಇಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0 can't be, because some area is covered by the graph, therefore it must be no, less than 1 ಅಂದರೆ 0. It cannot be equal to 1, it will be equal to 0. 1 ಆಗಬೇಕಾದ್ರೆ ಏನಾಗಬೇಕಾಗ್ತದೆ? ಎಲ್ಲಿ 0 ತಗೊಂಡು 1 ಇಲ್ಲಿ 0 ಇಟ್ಕೊಂಡು ಇಲ್ಲಿ 1 ಮಾಡ್ಬೋದು, ಅಂದರೆ 1 ಪೋರ್ಷನ್ ಯು ಆರ್ ಒಮಿಟಿಂಗ್. ಎಸ್, ಮಾಡ್ಯುಲಸ್ ಆದ್ದರಿಂದ ಮಾಡ್ಬೋದು. ಸಮ್ ಪಾಸಿಟಿವ್ ಥಿಂಗ್ ಈಸ್ ಇಗ್ನೋರ್ಡ್, ದ್ಯಾಟ್ ಕ್ಯಾನ್ ಬಿ ಡನ್. ಎಸ್, ಬಟ್ ಇಲ್ಲಿ 0 ತಗೊಳ್ಳೋದು ಸರಿ ಅಲ್ಲ ಅಂತ ನಾನು ಹೇಳಿದ್ದು. ನನ್ನ ಪಾಯಿಂಟ್ ಇಲ್ಲಿ 0 ಬರೆಯೋದಲ್ಲ, ಇಲ್ಲಿ 0 ಬರೆಯೋದು ನಾಟ್ ಪ್ರಾಪರ್, ಬಿಕಾಸ್ ದಿಸ್ ವಿಲ್ ಬಿ ಆಫ್ ದ ಫಾರ್ಮ್ 0/0. ಬರೇ ಡಿನಾಮಿನೇಟರ್ 0 ಆದರೂ ಅಡ್ಡಿರಲಿಲ್ಲ, ನ್ಯೂಮರೇಟರ್ 0 ಆದರೂ ಅಡ್ಡಿರಲಿಲ್ಲ. ಇದು ಬೋತ್ ಆರ್ ಬಿಕಮಿಂಗ್ 0. ವಿ ಶುಡ್ ಅವಾಯ್ಡ್ ದ್ಯಾಟ್. One more. As it is, I have not copied the problem, I have slightly changed the version. Actually, the problem, this is in your problem sheet. The statement says something like this: is less than or equal to, some number is given here. You are required to say whether the statement is true or false. That is the form of the question. It's in your problem sheet. I do not know number. I have slightly converted it. You are having this integral. You are not required to obtain its exact value. It's enough if you obtain an upper bound. Exact value, can it compute? Can you compute? Maybe possible, you have to think about it. But in this case, I am not interested in the exact value. It's enough if I obtain an upper bound. An upper bound which can be easily obtained. I am interested in that. What I do is, I notice that for every x in my interval 0 to 1, x is a positive fraction. Therefore, if you raise it to a power, value decreases. If you go on increasing the power, value goes on decreasing. Therefore, this x square certainly is less than x. Suppose you replace this x square by x, integrand takes a very simple form, and value you get will be an upper bound for the actual value of this integral. Because x square is less than or equal to x. And this is simply 1 plus 1/2, I think, 3/2. I think your question was, this less than or equal to 15/8, the statement is true or false. You have to identify that. ಅದು 15/8 ಮಾಡಿದೆ ಯಾಕಂದರೆ ನಿಮಗೆ ಮೆಥಡ್ ಗೊತ್ತಾಗಬಾರ್ದಂತ. 3/2 ಹೇಳಿದರೆ ನೀವು ಮೆಥಡ್ ಗೆಸ್ ಮಾಡ್ತೀರಿ. ಅದಕ್ಕೋಸ್ಕರ 15/8 ಸಮ್ ಸ್ಪೆಷಲ್ ನಂಬರ್ ವಾಸ್ ಗಿವನ್ ಅಷ್ಟೇ. ಓಕೆ, this much enough for today. We will continue tomorrow with more problems, more properties, more problems. ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಬರೆದು ಬಿಡ್ತೇನೆ, 1 second. Cannot integrate directly, exact value impossible to find for us, but you can certainly claim it is less than or equal to integral 2 to the power x dx. Do you agree? Because x is a number between 0 and 1, x power n must be less than or equal to x. And what is the value for this? This is easily obtainable. Limit apply ಮಾಡಿ. Final value will be 2 by log 2. For every integral value of, for every natural number n, value of the integral will be less than or equal to this. Enough. 2 by log 2 or 1 by log 2? Is it not 2 power x by log 2? Yes. What is